This question asks if you have to memorize any of this. But when you say any of this, I'm also a bit confused which part the student is actually referring to. But let me tell you what you don't need to memorize. You don't need to memorize the numbers. By numbers, what I mean is these numerical values. You don't need to memorize this, but you have to know the trends. And also other small things like what you see down here in this text, like neon gas, it gives a red orange glow. Things like that, they are not going to ask what color a neon lamp is going to give. I'm pretty sure they are not going to ask that. They have better questions to ask. So you don't have to memorize these kind of explanations, but in actual exam questions, they can use these kind of detailed explanations just to confuse you, just to make things look very complicated. So you don't need to memorize why neon gas give red. You don't need to memorize that neon gas gives red orange glow, but you have to understand and you have to know why neon gas give red orange glow. So looking at this part, what you don't need to know. That's something you don't need to know. But what you need to know, why the neon lamp give that glow. It is emission spectra, and you have to know how emission spectra occur, and then you should be able to draw the emission line spectra. And also, if you're given the emission line spectra, you should be able to draw the electron transitions related to each line in an energy level diagram. Now, things you need to know in addition to trends and all the other concepts, the definitions, like what is the first ionization, what is the second or third ionization, defining those you need to know. What is a line spectrum, what is a continuous spectrum, the difference, you need to know them. How do you set up an experiment to generate this emission spectra, like having providing a high voltage to a gas that is held under reduced pressure? Those things are good to know things. So at the end, what you don't need to memorize, it's just the numerical values. Those are the only things that you don't have to memorize. What you need to know and what you don't need to know can be easily identified by looking into previous exam questions. I'm taking only 2 questions as an example, but you can go through the previous exam questions and see how this part is being tested. See, in this question, it is not even asking about the first ionization. Instead, it is asking about the second ionization. So it's not asking for numerical values, it's asking for the trend. if you take the first ionization energy, you will find the trend of first ionization energy like this. This is carbon, nitrogen, oxygen. But that's not us. You're asked about the second ionization energy. So you're required to know why this trend occurs. It's all in the electron setup or the arrangement of electrons. This is the electron setup in the 2p orbital of these three elements. The first ionization energy involves removal of the first electron from all these, and removing electron from this setup of nitrogen is the hardest. So in the first ionization energy, that has the highest first ionization, but in the second ionization energies, what is the electron setup you are going to start with? I made a tiny mistake here. Actually, that is not the electron that is going to be removed in the first ionization of oxygen. You can remove this electron for the first ionization. So in the next electron setup, your starting electron arrangement for carbon is like this, and for nitrogen you are left with only 2 electrons, but for oxygen now you have the perfect half-filled electron setup. Now this half-filled state is very stable. Taking an electron out from here is going to be very hard. So which has the highest second ionization energy is going to be oxygen. So you never needed to use any of those numerical values. What you needed to know is like the electron configurations, relative energies of the orbitals, what kind of electron arrangement result in stable configurations, what is first ionization, what is second or third, fourth ionization. And in reality there's nothing to memorize. Once you learn few concepts like electron configuration, you can figure out most of the things. There is another question here. Now in this one it's asking for the first ionization energy in the decreasing order, and in the periodic table you are required to know in general how this first ionization energy goes from bottom to top. The ionization energy, the first ionization energy increase, and then from left to right also it increases. Looking at the elements you have, you will find hydrogen and helium towards this end, and then lithium, beryllium, boron, sodium. So obviously helium has the highest first ionization energy, and sodium has the lowest first ionization energy. And then here you have hydrogen as the next highest first ionization energy. And all you have to worry about is lithium, beryllium, boron. And you know what the trend is: lithium, beryllium, and then comes boron. So from this set, lithium has the lowest, and then boron, and then beryllium. This order leads to your answer option 2. So try your best to understand the trends, apply not just the first ionization, think about the second ionization, third, and so on.